In this video, we check which coefficient you should look at in a regression model. So you've just run a multiple regression model in R or another statistical software like PSPP or JASP. Can we focus on those big and juicy coefficients and ignore the small ones? Here are two reasons why this may not be a good idea. First, let's consider the scale on which these variables are measured. Here's a model with interest in politics as the outcome, and we have gender and age as variables. Absolute value of the gender variable looks like something, and isn't the age coefficient almost zero or negligible? Not so fast. Gender coefficient refers to categorical variable, so you're either female in this data or not. The biggest difference in the outcome variable can be the coefficient. By contrast, age is a continuous variable, and we can't just compare people who are different in age by 1 year, but also something like a person aged 20 with a person aged 60. To compare these two people, we have to take 40 times the coefficient, because the coefficient stands for the difference of one unity, 1 year. Now that tiny coefficient may suddenly look more important substantially. Second, let's talk about causality. Forget the empirical model in front of you and come back to the causal model you're interested in. Which one is the predictor variable and which are control variables? We want to avoid table 2 fallacy here. You may be interested in the statistical effect of age even though you know that gender is the big one, so to speak. Put differently, you may know or not care about that gender has a big influence on the outcome, but you're interested in the statistical effect of age once you already account for gender differences. This is what the coefficient captures. As always, remember why you sat down with your data in the first place and interpret accordingly. Bigger doesn't always mean more important.